So composite transformation, whoa, watch out for that thing. Somebody get that removed. So it's just, you know, we've been doing transformations. Now it's just doing more than one of them, okay? Right, so you might do a translation, then a rotation. You might do a reflection, then a translation, or something like that, right? And could be two, could be three of them, right? Now, what we're going to kind of investigate here is sometimes the order that we do them in might matter, and sometimes the order will not matter. It'll end up, the image will end up in the same place no matter what, okay? So let's just look at a couple here to see if the order does matter. So composite function, right, that's just a fancy word for saying more than one. So the first thing I want us to do here is a translation. That vector, what's that vector tell us? It's going to go which way? What? Right 3 in. Okay, and after we do that translation, they're going to do a reflection in the y-axis, okay? So we start with triangle A. I don't know where the B and C are, but okay. So they went down 3, or down, or right, stretch that. Get rid of all that.
So right.
Went right 3, and then down 5. 1, 2, 3, 4, 5. Okay, did the same for all of them. So it basically did, that's our translation vector. Okay? And then we reflected this in the y-axis. And here's the location then of A prime, B prime, C prime, where they labeled it. So let's now see if the order matters. So let's start now, same triangle. Now we're going to do first the reflection in the y-axis, right, over to here, okay, and then do the translation. So did the order matter here?
Yeah.
Okay. Oh, by the way, a reflection over the y-axis. Can somebody give me another name for that? The y-axis? X equals 0, remember? Okay? Okay. So here's another example. It's a rotation. So we'll kind of have to do the thing where you rotate the page, right? So you guys are going to try this first in one order and then the other order. So you remember the first step is to write down the coordinates of the points, right? And then you rotate the page the opposite way. Just to save time, I will give you the coordinates of A, B, and C here. So A is at 2, 8. B is at 7, 6. And C is at 7, 2. Okay? Now, is that a positive or negative 90? So it's going to go this way. So which way are you going to spin your book? The other way, right? Plot those points as if it's upright. Okay? Another one, take a minute, do that now. And then you'll do the translation. So I'm going to work on this while you're doing it. I'll make that more accurate. You don't need to get nuts with a straight edge or anything like that. So then we have A prime, B prime. So when you get done, your rotation should be about there. Okay. And then do the translation. Down 3, or right 3, right 3, down 5. 1, 2, 3, 1, 2, 3, 4, 5. Right? Then 1, 2, 3, 1, 2, 3, 4, 5. For that vector, that's only 1, 2, 3, 4. So here we have a, what are we going to call it? Double prime, right? And this will be B double prime and C double prime. Okay. Now, before you do it, the next one, do you think switching the order will change the result? Think it will? Sometimes it will, sometimes it won't. Okay? So take a minute and do the second part here. we start out with the translation. So I'm going to go A, 1, 2, 3, 1, 2, 3, 5, 1, 2, 3, 1, 2, 3, 4, 5, C, and it's only 1, 2, 3, 4. So here is A prime, B prime, C prime. And again, I'll go ahead and give you the coordinates of these, A prime, B prime, C prime, to make your rotation a little easier. So A prime is at 5, 3. B prime is at 10, 1. And C prime is at 10, -3. Okay? All right, so I'm going to do your rotation. Turn your page opposite way. I think it's there, right? No, it's not there. Not there. It's not there. That's A, B, C dot prime. You're able to get what I have up here? Take another second. So did the order that we do it in matter here? I wish they didn't do it. It did matter, right? Because in the first order, we ended up here, and now the result of it is way up here, okay? Why do you think the order mattered? Well, we have a rotation, right? What's different in the second one? I bet you it has something to do with rotation. Everybody think of why the order mattered here when we went and did the rotation part of it. Yes, ma'am. See, you kids put your hand in there and do it at your peril. Because now I'm calling on you. You got to answer. So I think what she's trying to say is the figure that we're rotating starts out in a different location. Is that what you're saying? Does that make sense? Okay. So the rotation started in a different location, so it'll finish in a different location than what has that. Okay? All right. All right, so let's go on to the next page here and talk about some notation, some composite notation that you'll see. You're going to need to know your way around. So, first of all, as we look at this notation, does everybody see this tiny little circle in here? Right? So that means something mathematically, okay? That means when you see that, think the word after or of, okay? So I'll just say that this thing here, put a note, that being the word after or of, okay? And that little circle always means a composite transformation, okay? And we get to other maths, it'll be like composite functions, okay? But right now it's just transformation. Double circle you read is of. So what we read here, everyone knows this capital T means a translation, right? And there's our vector, okay? And then we have a what? What's the lower r? Lowercase r? Reflection, okay? So which one of those do you think we'll do first? Because remember, that little circle means after or of, right?
So you do the reflection there.
Yep. So basically that says we're going to do a translation of a reflection, or a translation after a reflection. So when you see the composite notation, okay, the reflection of the y-axis, this thing here happens first. If that little symbol means after or of, okay, again, that's read a translation of a reflection in the y-axis. So you got to do the reflection first to do a translation of it. Does that make sense? Or after, okay? So down here, that's a reflection of a rotation. So which one gets done first? The rotation. Because you can't do a reflection of a rotation until you have the rotation done, okay? So you always do the second thing first, okay? That make some sense to you? So let's make sure we got this straight. So if we read this in English, if we do a rotation of 270 degrees about the origin, followed by a translation, the vector 9, -3, okay? Here's the notation. Does it look like this in your book?
No.
All blurred up like that?
No.
Okay. So hopefully you can see it better than I can. So right here, which of these two things are we going to do first? Okay, this one's, I'll put a 1 above that. And then secondly, we'll do the translation. Okay? 1 and 2. So down here, a reflection of the x-axis followed by or after a rotation, or of a rotation, right, of 180. Which of these two things are we going to do first? Right here, yep.
Okay.
Right, so you always do the second thing first, because it's like, oh, okay. So which, okay, down here, why don't you guys just take a second and circle the one you would do first. So they give you the composite rule, and then down below you circle which one you're going to do first. We're going to do that right now. Which one are we doing first? In A. That one? Yep, let's see, that always happens. Doing that, and then in B, which one are we going to do first? That a little large reflection, right? Which one? 1 y equals x. There we go. Okay. So let's see if we can go the other way now. Now they're going to give you the words, and they want you to write the notation. Okay? And they gave you the little circle symbol, right? Okay? So we're going to translate it by -5,3, followed by a reflection over the x-axis.
So it would be T.
Well, what goes here? Okay, reflection. So we're going to use a lowercase r, and what's our subscript going to say? X-axis, right? Make it a subscript. And then what goes here? Let's use our notation. Capital T with our little vector here, -5, 3. Get the idea? All right, try that second one. You guys do that. Hmm? Capital R? Yeah, rotation's capital. So what are we going to write in this first blank, kids? Capital T, translation, 11, 9. And in the second blank, capital R, we'll subscript what? O, 73 degrees. There we go. Okay? Just got to get used to it. When you see that notation, you got to switch the order. Okay? All right, let's go look at the next page here. Here's a common composite transformation, a double reflection over parallel lines. Parallel lines, you know, never what? Never intersect, right? So we're going to take a figure. We're going to reflect it in one of those lines and then reflect it in the other line. And let's see if we notice something that happens when we do that, okay? So we're starting out with triangle ABC. We're going to first reflect it in what line? Y equals -1. That would be this line right here. Cuts the y-axis at -1. So if we reflect it, it ends up going here, right? And then we're going to reflect it in the line y equals 3. Those would be parallel lines. And then it gets reflected up to here. Okay? So when we did the first reflection, we changed the orientation, right? Everybody agree? And then what happened when we did the second reflection? The orientation went back to the original, right? They have some distances in here. So between the line y equals 3 and y equals -1, what is the distance? 4, isn't it? Well, we'll get there. We'll get there. So the distance between the two lines is 4. Now, how far did this triangle move altogether when we did the double reflection? It moved 8. Does this look like if you didn't have this one in the middle, right? That reflection, and we're just looking at it, what would you say this transformation was? No, reflection, rotation, translation. Does it look like a translation? How far? Up 8, didn't it? And the distance between the line was 4. Okay, think about that. Let's go look at the next one. Okay? In the next one, we're going to reflect double reflection first. Oh, I forgot to put the 2 here, right? Okay? First over the line, x equals 3. That is, got that line.
-3.
Oh, that's a -3. Yeah, okay. X equals -3. Why is there not a line? Oh, over here. Okay, scratch. All right. My brain's shutting down. Okay, so we're going to start by reflecting it over that line. Okay? And then we're going to reflect it over the line x equals 2. So take that, double reflection. Okay? If we did not have this first reflection, does that look like a translation? How far apart are the two lines? X equals 2 and x equals -3. How far is it between 2 and -3? 5. But it looks like the triangle moved how far? 10. So this might just look like a translation in a particular direction, right? Okay? Depends on which line you reflect in first, right? If you're reflecting in lines of x equals something, it's going to look like a translation going left to right, right? Twice the distance maybe. And if you're reflecting in lines y equals something, it'll look like a translation going up and down. Okay? So it looks like we've concluded the following. A double reflection over parallel lines results in effectively a translation. Okay? And so this is important. That translation distance is double the distance between the parallel lines. Okay? So when we do a double reflection of parallel lines, it's effectively a translation that's twice the distance of the parallel lines. Okay? So let's take a look at this example down here. So what do they want us to do? Right here with that triangle. First, what gets done first? Reflection in x equals 1. Okay? And then reflection in x equals -4. So what do we expect will happen based on what happened before? Okay, yeah, so orientation will be the same, but where do we expect the triangle to end up? Will it be a translation, you think? How far? Okay, I think it'll be 10. So we might expect this to be a translation 10 units which way? Left or right? 10 units left. Let's go ahead and do the reflection, okay? So everyone right now just start reflecting the first time in x equals 1. So we got, so 1, 2, 3, 1, 2, 3. All right, make sure you do the right line. And that is at 7. All right, so that's going to be 1, 2, 3, 4, 5, 6, 7. Is that right? That doesn't seem right. That's not right. 1, 2, 3. Down 1, 2, 3. Yeah, that's better. Okay. And then C going to be yeah, 6. 1, 2, 3, 4, 5, 6. Okay. This 10 minutes. Okay, so here's my A double prime, here's my B double prime and C, not double prime, mercy. A prime, B prime, C prime. And now I'll do my reflection. The other one, maybe I'll use red for this one, I don't know. So there's going to be B, and C there, and that one like that. So it should be. So now we got C double prime, and this is A double prime, and here is B double prime. What? Something wrong? Look it up. Okay. So let's go to 6B. Did the double reflection result in a translation? Yeah, it looks like it took this triangle and look at the red one. Just split it. So I'm going to say yes, right? So yes, it did. And what was the translation? Oh, we already answered that. Translation distance was 10, right? What's the distance between the two parallel lines? X equals 1, x equals -4. What's that distance? 5. You could do that when you look in the grid, right? Between 1 and -4, you got a distance of 5. So that's 5. All right? So these aren't too complicated, right? So just know that the double reflection of parallel lines is going to be a translation, depending on the lines in the order in which you reflect them, either left or right or up or down. Twice the distance between the lines. Okay? Take a look at this here. Now this one asked you to do a reflection first, y equals -2, and then y equals -5. Just think about this for a minute. If we start somewhere and do a reflection y equals -2, and then at y equals 5, is this going to be moving up and down or left and right? Let's do this. Sometimes it helps to make a quick sketch of it. I think it probably will as well, right? So let's just make a quick sketch. So if I do that, here's my x, here's my y, it's a horrible arrow, whatever. Okay? So let's put in y equals -2. Here's y equals -2. And then 3, 4, 5, y equals. So now maybe you can see, okay, it's definitely going to move up and down, right? How might we know it goes down and not up? It has more to do with the order that we're reflecting in. So if we reflect in y equals -2 first, goes here, and then in y equals -5 goes there. That's true. Let me ask you this though. What if the figure we're reflecting starts out here? What if we start there and reflect in -2? It'd be like up here. And then reflect in what? Then reflect in -5. It ends up way down here. Did it still move down at the end of it? It did, right? Okay. What if we change the order? What if we started here and reflected in y equals -5 first? And then reflected in y equals -2. So you see the up-down depends on the order in which you reflected it. So it might be a good idea if they don't have a graph or make a quick little sketch, right? See which way it goes, all right? So in this case, it's going to go down, right? This between the parallel lines is 3. And how far down did it go? Well, the distance between the parallel lines was 3. Alternatively, you could read these words here. Okay, 6. I love how you guys sit and tool and the answer's right there. Capital letters. Okay. Let's see if you guys can work out, just like in your heads, or if you have to make a little sketch here from this one. So we want to, they already tell us. Never mind, scratch that. So this is reflecting in the X lines. So will this move generally up and down or left and right? And it's going to depend on the order reflected, right? It could go left in one order, and it's going to go right in the other order, okay? So let's look at these examples, I guess, would be the best way. Okay? So, first of all, line is going to reflect first in x equals 9, and then in x equals 4. So let's get the translation distance down first. How far will it translate if we reflect twice in those lines? What's the distance between x equals, 5. So which way do we think it's going to go? Okay, let's make sure. Let's make a little graph. So x, always make just a nice rough little sketch here, right? So here's, going to be way out here. Here's x equals 9, and then x equals 4, like here, right? So if we reflected 9 first, and then in 4, we expect it to go left. Even if we started on the other side, right? I showed you that in the other one, okay? And how far left will it go? 10. This is twice the distance between the lines. You guys try number. Are these lined up right? So that goes there and there. Don't seem to be lined up. Or maybe they are in your book. Oh, because we didn't. Oh, okay. I know what I did. That first one where I have the 10 there. That's not the translation, or the 5. That's not the translation distance. This is part of the. This is part of number 8. Sorry about that. That's why we do math and pencil. Translation distance. We're going to go 10. That's so this goes. Okay. Sorry. I just started dancing. All right. Now you guys try number 8. Figure out the translation distance and which way. Anybody give me the translation distance right now? Yeah, because between these two lines is 2. So our translation distance, now that we're looking at it correctly, is 4. Now you just got to figure out whether it goes up or down. What do you think? Up, down, left, or right? Guys agree it'll be up? If you have to draw a quick little sketch, do that, right? So we're going to go 4 up, right? I'll make it so if we did it like this, so y equals, here's y equals 2, here's y equals 4, right? So if we reflect here, it'll go there and there. Up. Okay? All right. This might be getting a little too long.